recording. And then I'm going to go to our Jamboard. So if you have your books open, you should be opened to 11.1.2. You'll see problem number 14 here. And how can I rewrite it? We are going to learn how to multiply and divide rational expressions. So let me get my pen up here. Multiplying and dividing rational expressions, which involves factoring. Okay, that's why I wanted you to have that factoring worksheet done today. Okay, we know how to multiply polynomial expressions, and you know how to multiply and divide fractions. So how can you use what you know to multiply and divide rational expressions? Today, we're going to figure that out. Okay, so problem number 14, again, we are in chapter 11, not chapter 3. We're skipping chapter 3. We'll come back to chapter 3, but going to chapter 11, we have 3x squared plus 11x. That's a minus 4 all over 2x squared plus 11x plus 12. Okay, and so we want to divide these two things. Okay, and what we don't want to do is this. Okay, we don't want to say, oh, these x squareds, I can cancel those out. These x's, I can cancel out. 4 goes into 12 3 times, and I can make that a 1 and 3. That's a big no-no. Okay, don't do that, because then you won't have any x's left, and that would just be wrong, wrong, wrong. So we don't want to do that. Okay, not allowed, definitely. Another thing is, how do we divide these two? Oh, we'll go over that next. So what we need to do is we need to factor. How do you do these problems? You factor, factor, factor. See how this is a trinomial and it's begging to be factored right here, right? So we're going to break it down into its two factors. And since the bottom one is also a trinomial, we're also going to break it down to its two factors. Okay, and usually I would use the diamond and the box method, but I don't really need to do that because these are really small numbers. So we can use just guess and check. Okay, so to factor, first I'm going to factor 3x squared. Well, the only way you can make 3x squared is 3x times x. Okay, and then next I want to factor 4, right? And I want to get it to be, I want the 3 and the 4 factor to make 11. Well, isn't 3 times 4 12? And then we can use a 1, subtract 1 to get 11 from that. So next we're going to, so since I know I want to make 12 because that's close to 11, I'm going to put the 4 here, right? Because I want to multiply 3 times 4 to get 12. And I'm going to put the 1 here and multiply 1 times x to get 1x and the 3x times 4 to get 12x. Because I could reverse the 4 and the 1, but that wouldn't give me the 12 that I need, because I know I need to get to 11, so I want to be close to that. So since this is a positive 11x, right, I want the 12 to be positive and I want the 1 to be negative. Well, in order to make the 1 negative, the minus has to go here and the plus has to go here to make this a positive 12. So I just factored that, guess and check, no X box needed. You know, if you did do X box, you'd have to multiply the 3 and the 4 and you'd have to put like negative 12 x squared up here and 11x down here and then do the whole box thing, but this is much quicker, right? And then our next one, we want to factor next, we want to take the 2x squared. So I'm going to split that up to 2x and x, right? That is how you factor 2x squared. And then the 12 factor is going to go here and here. Well, there's several factors of 12. I can use 2 times 6, I can use 3 times 4, but I'm going to use 3 and 4 because I'm looking at the middle term and it's an 11. And I know that 2 times 4, 2x times 4 is 8x. And then 3 times x is 3x, and that's going to make 11x. So that's why I picked that. If whatever numbers you pick, let's say you pick 2 and 6 and they don't work, pick another number or switch the 6 and 2 around. And then if that doesn't work, you try 3 and 4, or you switch 4 and 3 around. You try them until they work. But you do enough of these, you get enough practice, and you figure it out pretty quick. Okay, so I want a positive. These are both positive. So that tells me, hey, that's going to be a plus. That's going to be a plus. If this is a plus, there's a plus right there. If that's a plus, the plus goes right there. So this is what we have so far, okay? We have 3x minus 1 times x plus 4 over 2x plus 3 times x plus 4. Well, since these two factors are exactly the same, the x plus 4, they can divide out. So I can cancel them out, okay? They become ones, right? They don't disappear. They don't become zeros. They become 1 over 1. But what that leaves you with is this. We have simplified our expression to 3x minus 1 over 2x plus 3, okay? By factoring and canceling out the common factors. We didn't cancel out the x squared. You're not allowed to do that. You're not allowed to cancel out these 11x's, not allowed to do that. You have to factor them first and then cancel out the common terms.
Miss Wakefield?
Yes. Hold on one second. Hold on. Recording. Okay, so next problem, I need to clear this out. Everybody have that? If you don't, take a screenshot real quick because I have to go to the next slide. Or if you have your phone nearby, you could take a picture of it really quickly before I go to the next slide. All right, clear all that. Go to the next slide. Here we go. So number 15 says, hey, let's review multiplying two fractions and dividing two fractions, because this is going to help us with the rest of the work. Okay, so let's start with A here. 15A says 2/3 times 9/14, right? So basic multiplication of fractions. All right. If you recall, since this is a multiplication, not addition or subtraction, but since it's multiplication, I can cross reduce. 3 goes into 9 how many times? 3 times. And 2 goes into 14, right? So 2 goes into 14 7 times. So I'm just basically going to get 3/7. This is going to reduce down to 3/7, right? By cross reducing. You're allowed to do that. Or we could have just multiplied straight across. 2 times 9 is 18. 3 times 14 is, I don't know, 12, 1, 42. Okay, and then since these are both even, you would reduce them. It looks like 6 goes into both of these. 6 goes into that 3 times. 6 goes into that 7 times. So it reduces down to 3/7. I prefer the first way because you don't have to multiply the big numbers like this and just cross reduce. This one, cross reduce those two, cross reduce those two. Okay, so keep that in mind. We're going to use this practice in a second for the other problems we're doing. Now, if I look at part B here, 3/5 divided by 12/25. Okay. Remember when we divide fractions? We never divide fractions. We always change the division to, anybody? You're welcome to unmute yourself and comment. Let me know you're awake.
We like flip them and then multiply them.
Right, good. You're going to change that to multiplication and then you're going to flip this over. It's called multiplying by the reciprocal. It's usually the first time you find out about a reciprocal. 25/12. So we change the division to multiplication and then we flip this. We multiply by the reciprocal. Okay. And now I can cross reduce because this 5 goes into this 25 5 times. And this 3 goes into the 12. So 3 goes into 12 4 times. So basically I just get 5/4, right? That's how easy it is to cross reduce. Okay, so that's how easy it is to multiply and divide fractions. We're going to use this method for the next few problems. Okay, so if you didn't copy this down or you're just take a screenshot, I got to go on to the next slide. Okay, it's simple multiplication and division. You should be able to do it on your own. All right. Okay, next slide here. Okay, how can we apply these multiplication and division rules of the problems we just did to like rational expressions? Okay, so for 16a, my pen back, 16a, 11-16, we have 4x plus 3 over x minus 5 times x minus 5 over x plus 3, right? I'm just looking at straight from your book right there. Well, remember, you cannot do this, okay? You cannot like say, oh, I'm going to cancel out these x's because there's a minus here and there's a plus here and it ties them together. So they cannot be split up. Like you're not allowed to do that. Okay. But since both of these are x minus 5s, the whole factor is the same. You can cancel those out. And when I say cancel, they're becoming ones, right? They're imaginary ones. They're not disappearing. They become ones. It goes into this one time. I cannot cross cancel anything here. You can't cancel that 3 and that 3. That's bad because there's pluses tying these together. So you can't do that, okay? You can only leave it like this. 4x plus 3 over x plus 3. Can I cancel out these 3's? No, you cannot do that. You're not allowed to do that, okay? Because this is chained together. The x plus 3 are like joined together with this plus. This 4x plus 3 is joined together with this plus. So you cannot cancel the x's and you cannot cancel the 3's. You can only cancel them if they're exactly the same. Like if this is a 4x plus 3 and that was a 4x plus 3, then you could cancel them. But you can't here. Okay, and it does say to state any values of variables that need to be excluded. So we have excluded. So this is our answer right here, okay? Our answer is 4x plus 3 over x plus 3. Okay, what are our excluded values? Excluded values. So there are actually 2 excluded values. First is what value for x is going to make this equal to 0, you guys? Feel free to unmute yourselves. -3, right? If I put -3 plus 3, that's going to make it 0. You're not allowed to have 0 in the denominator. So one of the excluded values, x can be any number except -3. But then we have another excluded value here. And I'm going to include it for this one, for the x minus 5. Even though we canceled out the x minus 5, if we put a 5 in this problem, that's very problematic, right? If I put 5 minus 5, that's going to give me a 0 in the denominator. So I'm going to say the other excluded value is 5. X equals 5. So those are the 2 numbers that x cannot equal, because we're excluding those values. X can be all real numbers except -3 and 5. Okay, so let's take a look at B here. B says x plus 2 over 9x minus 1 divided by 2x plus 1 over 9x minus 1. Okay, notice, you got to take note. Is this a multiplication or division problem? It's division. So we need to change this to multiplication, and then we need to flip over the fraction, right? Flip over the second fraction, not the first fraction. So x plus 2 over 9x minus 1 times, and then I'm going to flip this over, 9x minus 1 over 2x plus 1. And that makes the problem nice because look what ends up being the same, right? So the 9x minus 1s are the same, so we can cross cancel those, cross reduce. I cannot reduce these two because they're not the same. So we're going to just leave this, the numerator, x plus 2 over 2x plus 1. Can I reduce anything in this? Absolutely not. Do we have excluded values? Absolutely, because there's a denominator. How do you find the excluded value? You set the denominator, the 2x plus 1, equal to 0 to find what value will make it 0. And then you solve that. Well, I'm just going to minus 1 from both sides here. You get 2x equals -1. I'm going to divide by 2. So my excluded value is -1/2. Let's see if there's any other excluded value we need to include. We could include this one right here. Because if that's 0, then that's bad too. So I also want to set the 9x minus 1 equal to 0. Okay, I'm going to add 1 to both sides here. And I'm going to get 9x equals 1, divide by 9, x equals 1/9. So the other excluded value is x equals 1/9. So there's 2 EVs, excluded values, right? -1/2 and 1/9. Because if I put 1/9 times 1/9, that's going to give me 1 minus 1, which is going to be 0. And we can't have 0. We can't have x plus 2 over 0. That would be problematic. So you want to figure out for the 2 values what your excluded values are. Okay. If I look at C here, C is over here. I'm going to write that down, right here. C is 2m plus 3. I'm going to draw a line to kind of separate this here. Over 3m minus 2 times, this is a multiplication problem, 7 plus 4m over 3 plus 2m. Okay. Can we cross reduce? Look, these are kind of the same, but you can't do sideways stuff, right? You can only, when it's multiplication, you can cross reduce. Are any of them the same? Yeah, basically these are the same. This is, if I reverse this, this is 2m plus 3, right? So that's 2m plus 3. So they're the same. So they can cross reduce. This is 4m plus 7. This is 3m minus 2. I'm going to reverse this because this looks weird. I'm going to make it 4m plus 7. We like to put the variable first. So I'm going to switch those two around. It's addition. You're allowed to do that. And this is 3m minus 2. We're not allowed to cancel the m's, right? Because there's pluses and minus connecting this stuff. So we can't reduce anything else. So that's going to be your answer. We need to find an excluded value. So I'm going to set the denominator equal to 0 and solve it. So I'm going to add 2 to both sides. 3m equals 2. Move my control bar out of the way here. Okay. And then I'm going to divide by 3. So one of the excluded values is 2/3. M equals 2/3. You're not allowed to have that. The other one is, so we did the 3m minus 2. We need to set this one equal to 0. If I set this one equal to 0, I'm going to get negative 2/3. Right? Same problem, just with the plus. So those are my two excluded values, positive 2/3 and negative 2/3. Those are excluded values. Don't just put m equals. That's not what m equals. Those are the excluded values. M can be any other number except these two numbers. Okay. I need to erase this section over here. So, and I'm going to be erasing this stuff. So if you need to take a screenshot, then go ahead. But I need to make more room. So let me erase this guy right here. Okay, so let's see, draw again. Let's do D. D says y minus 2 quantity squared over 3y times y plus 5. This one right here. That 5 looks pretty funky. Let me redo that. Y plus 5 over y plus 2 times y minus 2. Okay. So we look for things that we can cross reduce. Okay. This y minus 2, squared, let's change that to y minus 2 times y minus 2, right? That's what y minus 2 squared. So I'm going to change this to that. Why? Because I see that there's one of these is a y minus 2. So I'm going to cross reduce one of those, leaving one of those behind. And can I reduce anything here? Can I cross reduce 3y and y plus 5? No, because this has a plus and this doesn't. So you can't reduce those y's. So basically I need to multiply these two here and get y minus 2 times y plus, but you don't have to multiply them out, okay? You do not have to multiply them out like we want to, like you could do first outer, you don't, you leave them alone. Over 3y times y plus 2, right? This y plus 2 is still down there. And you're not allowed to cancel these. You're not allowed to cancel these y's. You can't cancel anything else unless they're exactly the same. So this is our answer. Okay. And we have two excluded values, right? Because there's two y's. What's going to make this part equal 0 if y is equal to 0, right? So one of the excluded values, if this is 3 times 0, that's going to make the denominator 0. And then we need to set this equal to 0, the y plus 2 equal to 0. Well, that would give us y equals negative 2. So your other excluded value is y equals negative 2. Okay, those aren't the solutions. Those are the excluded values. Y can be any number in here except 0 and negative 2. Okay, so let's do E and F. I need to clear my screen. So If you need to take a screenshot, do that quickly because I gotta
This
clear.
week it says cube, not squared in the book.
Oh, does this say cube? Sorry, it's really tiny. I can't see it. Thank you. So since that's cubed, let's add another y minus 2 of here. I didn't see that. So I need to add it. So there's going to be another y minus 2 over here. So I'm just going to make it squared right here. Okay. So that's just going to change our answer by putting a squared right there. So instead of just y minus 2 times y minus 2, it should have been y minus 2 times y minus 2 times y minus 2. So there's 2 of them, and I still can't cancel one of them with this because this is a minus and that's a plus. All right, thank you. And you know what? I'll just go ahead and erase all this stuff. And so that's there. You guys can make that correction there. I don't want to make it disappear. People got mad at me yesterday in my other class for erasing things too quickly. I don't want anybody to be mad at me. That would make me very sad. Okay, so what are we on? F. So let's copy F. This is 5x minus 2, 5x minus 2 over, thank you for that.
What about E?
I thought we were on E.
Oh, thank you. I was trying to skip ahead. Okay, 3x plus 1. Okay, we'll do E. So I'll save that for later. Here's E. E is an easy one. Shouldn't take long. 15x, that's a cubed, right? Yeah, cubed over 3y divided by, can I go ahead and change this to plus to times, guys, and flip this over, right? So I'm going to change it to times. I'm going to flip it over. So 4y squared over 10x squared y. Okay, so it's a division problem, so I'm changing to multiplication and doing the reciprocal. Okay, we can cross cancel a lot of things in here because there's no pluses or minuses. You just got to be careful that you don't get confused when you start canceling everything. I'm going to go ahead and cancel like 10 and 15. 5 goes into both of them, right? So 5 goes into 10 2 times. 5 goes into 15 3 times. And you see this y and this y, if I multiply y times y, wouldn't that be y squared? So I'm going to go ahead and cancel both of those with this y squared. And I can cancel this stuff, but let me just write it. I don't want to get it too confusing. So I'm going to write what I have so far. I have an x cubed, but I also have a 3 out in front. 3x cubed, times 4. Forgot the times 4. Over 3, there's another 3 down here. Times 2, forgot about that. And times x squared. Okay. So I see there's a 3 on top and bottom. Yes, you are allowed to cancel those because this is all multiplication. So I'm going to cancel the 3's. The 2 goes into the 4. 2 goes into the 4 2 times. And since there's 3 x's here and 2, I can cancel this and leave 1 left, right? Because there's like 1, 2, 3 up here, and there's 2 down here. So these 2 are going to cancel with these 2, leaving me with 1x. So I have 2x on top, this 2 and this x over nothing, which is over 1, right? If it's nothing, if everything cancels, that's a 1. But I don't need a 1 in the denominator, so it's just all going to cancel down to 2x. Okay. If you just put 2x on your paper with no work, I'm not going to give you credit because look how much work I had to do. I had to cross cancel all this. I had to flip it over. I had to cross cancel all this. So there needs to be work on your paper, okay? If you just say, oh, I did it in my head, well, your grade's going to be in your head too, guys. You have to show work, okay? Always show work. All right, I didn't do that in my head. And if I did it in my head, you wouldn't understand what I did. All right, so F, 5x minus 2 times 3x plus 1 over 2x minus 3 squared. And then I'm going to have to, sorry, but I have to erase this. If you need to do a screenshot, please do it really quickly because I got to erase this to make room for this part of the problem. Lately, I've been posting my videos because people have been missing for whatever. Like today, somebody has a doctor's appointment and it's kind of an extra step for me to post the video, but I can't post videos all the time, you guys. I don't have time to do that, and you're supposed to be here. So, but sometimes I have time to do that. And if it's a really important lesson, like last week's was really important. So I'm going to go ahead and change this division to multiplication, and I'm going to flip these over. Okay, so this is x minus 4 on top. And what? 2x minus 3 is now on top. And then the numerator is now going to be the denominator, 5x minus 2 times x minus 4. Okay, so that is problem F there. Okay, anything that's the same that we can cross cancel? Definitely, I'm definitely seeing some 5x minus 2, 5x minus 2, right?
X minus 4.
And then
2x
x minus
minus
4 is right. So
2x
one's on
minus
top,
3.
one's on bottom. And then this 2x minus 3, there's 2 of them here. There's only 1 of them here. So watch what I'm going to do. I'm going to cancel this 1, and I'm just going to cancel that 2 and just leave it as 1. Okay, so there's only 2 things left now. This is your numerator, and this is your denominator. So it's 3x plus 1 over 2x minus 3. It doesn't get any more easy and beautiful than that, you guys. That is, okay. That is as easy as it gets. We do need to put an excluded value though, right? And technically all these are supposed to be our excluded values. Yeah, let's do all of them. So this one, if I set this equal to 0, I'm gonna just say it's 3/2, right? You solve it. I can do that in my head. If I solve this, I'm gonna add 3, divide by 2, 3/2. The other excluded value was right here. If I set 5x minus 2 equal to 0, I'm gonna get 2/5. Okay, you should be able to pretty much do those in here. If I set x minus 4 equal to 0, I'm going to get 4. So there are 3 excluded values because there are 3 denominators. Okay, really there's 4, but this is a duplicate. So 1, 2, 3, 4. X equals 4 will make this 0. X equals 2/5 will make this 0. X equals 3/2 will make this 0. So you have 3 excluded values. All right, voila. Ooh, that was a lot of work for 16. I need to go to the next screen and clear the screen. So if you need to take a screenshot, do so. But I need to go on. Okay, clear my drawings. Move this out of the way. Next slide. Okay, this is the last slide. I know we're having so much fun. You're sad, I know. All right, color blue. Okay, 17a, multiply or divide each expression below. For each rational expression, you can assume no denominator is equal to 0. Leave your answers as simplified as possible. So this is just more of the same. So, okay, 17a, let's do 17a. 20 over 22 times 14/35. Well, I'm like, hey, this can be reduced. You know, 2 goes into this. How many times? 2 goes into 20, 10 times. 2 goes into 22, 11 times. So that can be reduced to 10/11ths. And I'm looking at this and I'm saying, hey, 7 goes into both of these. 7 goes into that twice. 7 goes into that 5 times. So now we just multiply straight across. Okay, 10 times 2 is 20. 11 times 5 is 55. And then always check, can you reduce this? Because half of you are going to give me this answer and say, I'm done. No, 5 goes into both of these because this ends in a 0 and that ends in a 5. So 5 goes into both of this. 5 goes into that 4 times. 5 goes in that 11 times. 11 doesn't go into 4. So that tells me this is reduced to its lowest terms as simplified as possible. If you don't simplify it all the way down, you leave it like this, you get points marked off. Okay. B says 12/40 divided by 15/6. Okay, go ahead and change that to a multiplication problem while I check the chat box. Yeah, that's fine, Fernando. I got your message. You can go. So we always want to change your division to multiplication. So 12/40 times reciprocal 6/15. Okay, I'm noticing 4 goes into these and 3 goes into these, so I'm going to reduce them. Okay, this is why being good at times tables is good. 4 goes into this 3 times. 4 goes into that 10 times. 3 goes into this 2 times, 3 goes into that 5 times. Okay, so you're allowed to reduce up and down. I'm going to multiply straight across. 3 times 2 is 6. 10 times 5 is 15. I'm noticing again, 3/15, 3 goes into this. That was 6/15, so it's going to reduce down to 2/5.
Isn't 10 times 5 50?
Did I mess up? 10. Oh yeah, sorry. I was thinking of something else. Thank you. So let me erase that. When I try to go too fast, I make mistakes. Pen, where's my pen back? Okay, 50. Thank you. 10 times 5 is 50, not 15. And there's nothing that goes into both of these, right? 2 and 3 goes into this, and 2 and 25 and 5 goes into that. So it's just going to be 6/50. Oh, just go like that. That's your answer. Okay, so thank you for that correction.
Wait, wouldn't it be 3/25?
Oh yeah, reducing it. You're right. There's a 2 that goes into both of these. I could have, thank you. 2 goes into, I didn't see, there's a factor of 2 here, and there's a factor of 2 here. So we can reduce it by 2. Thank you. 3/25. Thank you. Speaking of reducing, there you go. That is in lowest terms. Thanks. For C, we have a division problem. So let's take a look at this. 5x minus 15. Maybe I'll just do C and D, and I'll let you do E and F because they're kind of, I don't know. We'll see. 5x minus 15 over 3x squared plus 10x minus 8 divided by, well, I'm going to change that division to multiplication, okay? I'm going to change this division, and I'm going to flip it around. 3x squared minus 8x plus 4 over x squared plus x minus 12. Okay, so I changed the division to times, and then I flipped this around and put top and bottom, bottom and top. Okay, you cannot cancel any of this, right? We have to factor, 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 factor. All of these can be factored. So let's factor them. What can be factored out of 5x and 15? A 5. So I'm going to take a 5 out. If I take a 5 out of this and a 5 out of this, that's going to leave me with x minus 3, right? Everybody see that? Take a 5 out of that, a 5 out of that to get it back. If I multiply 5 times x minus 3, that's 5x minus 15. Let's go ahead and factor the 3x squared plus 10x minus 8. Well, I know it's going to factor down to 2 binomials. To get a trinomial, you multiply binomial times binomial. To factor 3x squared, well, that's just 3x times x. That's the only way you could do that. 8 needs to go here and here. That could be 2 and 4. Let's see, will 2 and 4 work? Yeah, 2 and 4 is going to work because, how do I know? Because I did this in my head, because I've done so many of these as a kid. When I was your age, it becomes second nature. 3x times 4. The only way to get good at this, you guys, is just do a whole bunch of them. Okay. I wasn't born with math ability. Like, I did a lot of homework to get good at it. Okay. That's the only way to get good at it. Okay. So you see, I have a 12x here and a 2x. To make 10x, this is going to be positive 10x. This needs to be positive and this needs to be negative. So my negative is going to go here and my positive is going to go here. Okay, so far I have nothing I can cancel, but I suspect when I factor these two, I'll have more to cancel. Okay, so I'm going to factor the 3x squared. This is factoring 101 right here. 3x times x. I split the 3x to 3x times x. The 4, I can do 4 and 1, or I can do 2 and 2. And I think it's going to, yeah, it's going to be 2 and 2. I did that in my head because I knew this was going to be a 6x when I multiply those two. I knew this needs to be a 2x to make negative 8x. Well, if I need it to be negative, this has to be negative and that has to be negative, right? So they both have to be negative. So it doesn't really matter where I put it because they're both negative. And a negative times a negative 2 times negative 2 gives me my positive 4. So that tells me it's correct. Okay. I didn't have to use diamonds. You could do this in your head. Okay. This one, pretty easy. You know, that's an easy diamond one. I put negative 12 on top. I put 1 because this is a 1x on bottom. 3 and 4 differ by 1. So I know it's going to be 3 and 4. It's a negative. So this one's going to be positive. This one's going to be negative, right? So how do I factor this? X plus, minus 3. I'll just put x plus 4 times x minus 3. Then I don't have to erase it. X plus 4, x minus 3. Now that we factored everything, we factored all 4 terms. Now I can start canceling things. You can't cancel until you factor everything, okay? So let's look what's the same. I see a 3x minus 2 here and a 3x minus 2 there. I see an x minus 3 here and an x minus 3 here. I see an x plus 4 here and here, but they're both on the bottom, so I can't cancel those. I need to double them, basically. And so what's left is a 5 times x minus 2 in the numerator. Okay, and the denominator is going to be 2x minus 4, so x minus 4 squared. And you're not allowed to cancel these, so that's our problem. Does it say to, it doesn't say to put excluded values, but I'm just going to put right now, excluded value is 4, right? X equals 4, because you can't have 4 minus 4. You don't want the denominator to be 0. There are some other ones, but don't worry about that for now. Just, that's good. Okay. And then D, I'm going to change my color here. Let me mark this off. So we're getting kind of crowded here.
Miss Wakefield, is it not x plus 4 squared?
Oh, sorry. Yes, thank you. X plus 4, not X minus. Thank you. Again, I'm trying to rush through that. So X plus 4 instead of minus. Thank you. Let's look at D. D says, I need to erase this. So I'm going to erase this. Need more space. Like my little artwork, guys, I try to jazz things up today. I was like, man, this slideshow is too just plain. I need some color in my life. I like art. I'm an artist. I actually paint watercolors and acrylics if I ever have time, which is hardly ever. So let's see. D, put it up here. 12x minus 18 over x squared minus 2x minus 15 times, so I don't have to flip anything over because it's times x squared minus x minus 12 all over 3x squared minus 9x minus 12. Okay, yeah, I think this is the last one I'm going to do, guys. You guys can do the last two because they're basically the same as the last two I just did. Okay, you cannot, if anything's, these are not the same, these are not the same, so we can't cancel them. So we have to factor everything, factor 4 times, right? Factor this, 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 and this. So this is a binomial. How do you factor a binomial? It doesn't have 3 like this. So you just take out the greatest common factor. What's the biggest thing that goes into 12 and 18? 6, right? Not 2, not 3, 6 is the biggest. So we're going to take out a 6 out of both of these. Well, I would have to multiply 6 by x minus 3 to get 12x minus 18. So that's what goes in there. That's how you take out a 6, take out a 6. For this guy, it's a trinomial. So I'm going to make it a binomial times binomial. I'm going to put 15 on top. Well, that's just 3 times 5 and negative 2 on bottom, right? And one of these has to be negative. So the bigger number has to be negative. So x plus 3 times x minus 5. Can't cancel anything out yet. Now I want to factor this guy over here. Didn't we just factor that one? We kind of did over here. It was down here. So I know I'm going to use 3 and 4 because we did that over here already, right? So x is how you factor x squared. For 12, I'm going to use 3 and 4. I want a negative 1 this time. So I want negative 4, positive 3. Didn't even need to use the diamonds, okay? But you could. Last one, I want to factor this guy. Ooh, there's a 3 that goes into all of them. Let's take out a 3 first, okay? You want to take out a 3 first. You need to do that. If you don't do that, the X box doesn't work. So if I divide this by 3, this by 3, this by 3, what is that going to leave me with? X squared minus 3x minus 4. Okay, so I want to put this 3 out in front. Now I'm going to factor this guy, which is pretty easy. X and X go here for the X squared. The factors of 4 that differ by 3 are 1 and 4. I mean, you can use a diamond for that. I need it to be a -3, so it's going to be a -4 and a +1, right? Because this will give me 1x, this will give me -4x, that'll give me -3x when I add these two together. The more of these you do, the better you get at factoring. You can start doing them in your head, but you have to do lots and lots and lots and lots to get good at them. Okay, now I can look to cross cancel stuff. So let's see, what's the same? I see an x plus 3 here. I see an x plus 3 here. I see an x minus 4 there and there. And I see 3 goes into 6. 3 goes into 6 2 times. And I think that's all we can cancel, right? So what do we have left in the numerator? Just 2 times x minus 3 here. And you do not multiply it out. Okay, don't multiply it out. Leave it factored. Do not distribute. Don't do that. I know you want to, but don't. Fight the urge. Okay, and this one is just x minus 5 times x plus 1. Kind of like to put the lower number first and then the bigger number second. Okay, I'm going to try to slow down, make sure I don't make mistakes. When I go fast, I make a bunch of mistakes. 2 times x minus 3, x plus 1, x plus 5, that looks good. Nothing else can cancel. I do want to put excluded values. There's 2 excluded values here, right? X equals -1, we'll make this part 0. And then 5 will make this part 0. I could just look at that and see, I don't really, that's mental math. So this is our answer. This is our side note, our excluded values. All right, guys, so I've done a ton of examples. So now you got to finish up E and F. Okay, so you factor everything, factor, flip that over, change it to multiplication, factor these two are already factored. You can cross cancel the 5x and the x. There's something I need to show you on the next page. So you need to do those two. And then the rest of them that you have to do are these guys here, 19, 20, 21, 22, and 23. 23 is the, what do you call it? The compounded, sorry, I gotta get my pen back. Compound interest, right? You need more practice with that. That's probably gonna be on a test or a quiz. We are gonna have a quiz, and let me let the cat out of the bag on this one. Exciting news flash here. Those of you who stayed to the end, here's your reward. We're probably not gonna have a regular test for this chapter. We're gonna have a project instead. So instead of doing a chapter test, there's going to be a project for this class, and we're working on it. What it is, I'll tell you later. We don't have all the details yet. We're working on it. Me, Miss Holly, and Mr. Hayden are working on it. But we'll have details sometime after Thanksgiving break. All right. So we're excited about that. You know, not going to have a test, just going to be a project, and you're going to get to present them. And that's going to be your final exam too. You're going to get to present your projects. Isn't that awesome? So no final, it'll just be presenting your project, which is awesome. Another thing is, so we are going to have a quiz on this chapter though. So I suspect compound interest is going to be on there. So please do 23 very carefully. Look at your notes. There are lots of compound interest videos. If you didn't understand the last video that I did, it was on there. You could watch that video too. For 22, I did want to explain what does it mean for something to be closed under multiplication. So this is saying, hey, if you multiply a rational number by a rational number, like, I don't know, 2/3 times 1/5. You know, what are you going to get a rational number? You're going to get a rational number. A rational number is just a fraction. If you multiply a fraction times a fraction, are you going to get a fraction? And whole numbers count as fractions too. So even if you get a whole number, you can make it into a fraction. So we call that, we say, yes, it is closed under multiplication. Closed means you're going to get the same thing. If I have rational times rational, I'm going to end up with rational. So yet, yes, rational numbers are closed under under multiplication. Okay, and then it asks you, is it closed under division? If you divide 2/3 divided by 1/5, are you going to get a rational number back? Yes, you're going to get 10/3. That's a rational number. So if you divide a rational by a rational, you're going to get a rational. So it is also closed under division. Okay, so this is something you use in upper level math. If you take abstract algebra, when I took college algebra, we talked about closed sets. We don't talk about it a lot now, but that's what it's for. Okay, so you just need to go back and do 19, the last two of 18, 19, 20, 21. I just explained 22 to you, and then 23 due by midnight tonight. Okay, 11:59 technically. And let me